after all, there are miracles. So, AI, why now? As so let's just check time. There are now several things in place which allow to have very efficient AI systems. So I will be a bit quick here. So it's the key enablers are the computational power we have, the availability of large data sets, and so on. And so these are the external factors. And if we see the VC business, there is a lot of investment in AI. However, most investment is done in machine learning. Machine learning per se is a bit overrated currently. So when we talk about machine learning and intelligence, this is only a fraction of what intelligence could be. Yeah? So the state of the art of machine learning today is, take it with a pinch of salt, is by and large mainly based about pattern recognition. So pattern recognition derived from huge data sets, but this is only a fraction of what can be done in intelligence, and it covers only a part of learning. So learning from few examples, or transfer learning, reasoning by analogies or so, this is something which machines by and large are not very good at today. And so if people are afraid that they could be replaced immediately by an AI, in my book it tells you more about the type of a company which thinks that it can replace humans by AI, so perhaps they don't make proper use right now of human intelligence. So as it is today, there's still a long way to go for AI. However, there are specific areas where indeed machines today outperform humans. In pattern recognition, for instance, in well-defined environments. However, and this is something which can be leveraged and used for very interesting applications. Take autonomous drivings. So we have here a generic architecture, this sense, plan, act cycle of intelligent agents. And basically a car and different and similar approaches can be mapped to this generic architecture. So, and the challenges we are facing here, so in the sense part, we have this perceptive means. And this by and large works by deep learning networks. For the planning thing, we use normally other ways like graph-based models so that we can understand the cognition, the computation which is going on there. And then at least here in this, the last part in this architecture is acting and communicating with the actuators. Earlier at the panel, somebody pointed out that this can be compressed, those steps, in one big network. That's true. However, if you want to place to sell autonomous cars, you have to be able to explain how they work, and it's about risk management. In each part, this sense, plan, act part has to be properly understood and for verification and validation explained. And this is easier if you divide and conquer. Instead of having one big monolithic system, you should explain. At the end of the day, what this is about is that the autonomous agent is able to take proper decisions. So decisions here in the field, a pedestrian is encountered, and how should the agent act? Should he give way, brake, or what? So in an optimal environment, it looks probably like this. We have this neural network, this deep learning network, and visual input is digested. And what we see here is an example of semantic segmentation. So everything is mapped into one of those 20 classes. And so this environment is well understood. prerequisite for that is stability and reliability of the sensing part. However, this can't be taken for granted. We see that by and large there is a certain stability in perceiving objects. So even if an object has been played with, it still can be mapped to the class where it's an instance from. However, there are adversarial attacks. We saw plenty of them during the talks today, and so I don't have to outline the technology. But basically, this leads, you can fool systems. So this one is then recognized incorrectly, of course, as Russell Crowe. And this sticker is then interpreted as a speed limit. This is nice in a research paper, but in a real traffic situation, this could be dangerous. Things like that could kill people, could cause accidents. And so it's our duty to think about how to cope with that challenges, how to make systems resilient and secure and safe. And which works on individual pictures might even work on footage, on videos. I give you an example here. Generic adversarial perturbation is applied to this footage, and you see all the pedestrians from that have vanished. So in the terms of this sense, plan, act architecture, the sensation has been fumbled with. So no human object is recognized. Accordingly, the plan is devised and action is triggered. No way is given, and the car tries to continue to maintain its heading, which might have catastrophic results. So this actually is a big challenge, and since you are IT professionals, I think you will be aware that the current state of affairs in IoT security is there is headroom for improvement still, and this holds true if for the normal behavior of systems if people do not put effort in attacking systems. In attacking systems, in attacking AI systems on embedded devices or on autonomous cars, on things which are safety critical, this is really risky. And there are other challenges as well. So bias in data, pre-major implementation, half-baked solutions, or then on purpose made malicious design, harmful strategies. So there's a lot of possible danger coming from AI, and balancing that out, reducing the risks, and applying AI in a helpful way, so that it serves life and can help people to solve interesting problems, because AI is an incredible powerful tool. It helps us digesting complexity, something people are not necessarily good at. So what we could do here is, for instance, the Bosch Center for Artificial Intelligence tries to address those basic challenges with directed research efforts. So regarding the data input and sensing part, a lot of effort is put into making deep learning better understandable, explainable, and giving guarantees about what a system has learned and in which boundaries it might behave. And so this verification and validation of deep learning networks is a very interesting and important branch of research right now. Guaranteed generalization, so predicting how a trained model will will deal with new situations. This is a field of utmost importance for autonomous driving because, let's face it, you can't train a system completely so that it has seen everything. There are corner cases, rare events which are by definition rare. So it's difficult to cope with them. And here, research efforts go in a way that, first of all, you try to predict the boundaries in which a system will behave. And for the rare events, you have to work with simulations as well, trying to predict and simulate rare events, things which could happen but are unlikely. However, to be on the safe side, a system has to be capable of dealing with that as well. When I talked earlier about the money which is invested currently in AI, a large set of that money doesn't flow in companies which work on the real technical side of AI. However, there is many companies live from preparing data for AI. So for labeling data, a lot of companies which provide labels for data which then is used for training of AI systems, for driving, or for industrial automatization. So AI, as we have it today, is a very labor-intense business, since we use people for manually labeling data so that systems can learn in a supervised way from that. And this is something which is not ideal. So we try to utilize structured knowledge about domains, and taking context information so that systems can learn by themselves. I give you a short example. For instance, this MNIST dataset. You can either learn pattern recognition by labeling a large subset of this dataset, or you can use structured knowledge. You can tell the system, hey, basically there are 10 numbers, and each number is different from each other. And so you reduce the pattern recognition problem to a search problem. You compare one by one, and then you end up with 11 classes, 10 for the numbers, and one class of where no similarity has been established. So this is a simple example how context knowledge can be used for helping systems to learn by themselves. And of course, the ethical problem, we had the talk earlier. This is something which is really important for every one of us, because society, so far, there was always this connection between if you can act, you have a certain responsibility. And how will that be with intelligent systems? Our society has organized this connex between acting and responsibility for all animals, for all things which are considered to be intelligent. People are expected to develop some sort of responsibility until the age of 18, or at least then 21, then they should really have it. With house breed or pets, the owner or holder is responsible for that. So here again, the responsibility is properly distributed. But robots, intelligent cars, this is something entirely new, and society will have to decide how to deal with that. So it's a due care problem, and we have more challenges regarding making systems from the engineering point of view resilient and stable, because as I outlined earlier, so cyber attacks are imminent, something which happens regularly, and they become part of warfare today. And autonomous cars, autonomous vehicles, and intelligent plants and infrastructure has a big attack surface. So secure and robust software development and system engineering which is utterly required for bringing AI and intelligent systems in the market. So I try to make 5 minutes good. Thanks for your kind attention, and hopefully you are now so interested by those challenges that you decide you want to dedicate at least a part of your work life solving that. And if it's appealing for you, reach out to me. We are still hiring. Thanks for your kind attention.
Thank you very much. Thank you very much. So, before concluding, yes, please. Yes, why not? We are in the end, so if you want to ask him a question, yes, this would be interesting. Come.
Hi. Okay, so what, in your opinion, will make AI closer resembling human intelligence? Like you spoke about how it's not very understood, right? So deep learning, they make decisions, but what's the rationale behind the decisions? Or you train a classifier or a model to behave a certain way, and then when it has to learn on its own or generalize, it faces a challenge. What will move and push technology to be closer to the way humans behave?
Thank you. So it's basically the problem of embodiment. I don't see it as the ultimate task of AI to mimic human behavior, because, well, there's already human intelligence, and the quest for AI is more or less to understand what intelligence is and implement it for different purposes on a different hardware. So in my book, AI can be completely different from human AI, but it should be considered by humans as helpful. And what will bring in the disruption here and the progress, those are the application cases. So for instance, an intelligent vehicle, an autonomous vehicle, will behave then differently than a car which is driven by humans. But they should be able to interact with each other safely. Does this answer your question? So the gist of it is it can be a different intelligence than a human intelligence, yeah? But it should be safe, secure, robust, and be able to interact with other beings, yeah, safely and stable. Thanks.
Thank you very much. Thank you very much. So, we come to the conclusion of this part, and I want to say thank you very much for all of you. I know it was a long day. For me, it was amazing, learning so much, seeing that you didn't left, especially after lunch. So this said that it was probably interesting also for you. And what we will do now is a break of about 15 minutes. And after that, we are going to have here a special session, not related to AI, related to cyber and other perspective of cyber. So take the time. We will have a movie here. I promise you in the morning, we will have a movie with two representatives. One is called Ziv, the other one is Ilan. Ilan, you are here? I didn't saw you. Ilan? He is already drinking the beer outside. So you can imagine yourself what will happen here in 15 minutes. So, Ilan is with the beer and probably with, as I know him already for many years, is probably drinking also whiskey. And again, thank you very much for attending. Want to see you tomorrow and the day after. And thank you very much. It was a wonderful visit.